This video is going to look at simplifying radicals with different indices and also with variables. I'm going to throw some numbers in front as well, just to show you what you could do if there was something that started out in the front. You would just multiply by what you bring out. So this is 5 cube root of negative 384. We're adding in some extra elements with this as well. X to the 6th, y to the 4th, z to the 5th. So we'll show you some options of things you can do here. The first thing that's really important, anytime you have a negative sign, and you're only going to see the negative signs with the odd index, you can bring that out. So I'm going to bring the negative out in front before I even do any ounce of simplifying. And then groups of n can also be written with exponents with leftovers. So that's something we're going to do in our next option, or kind of like a hybrid option. So that note might not make sense yet, but I'm going to do that with our second example. There's going to be times where writing everything out is going to be very impractical. So this might be something that you would do. This is going to be kind of a long one, so we're going to do a nice good factor tree here. Again, I started out by dividing by 4. Not really sure why I did that, but you can start out with 2's. It's just going to make it a little longer for you if you do that. And then 2 and 48. I know 6 divided by 8, or 6 times 8 gives you that. If you divide by 6, you get 8. So we get 3 and 2. And then 8, you actually get 3 2's. So 2 times 2 times 2. So I'm just going to separate that out. You can also make it 4 times 2 and then split that up after the fact. Now I'm going to write out this really long thing going on here, and I'll show you a different option in the future. I have 1, 2, 3 2's up top, and then another 4 2's down below. And then I have 1, 3. So just make sure 1, 2, 3, 4, 5, 6, 7 2's. 1, 2, 3, 4, 5, 6, 7. Now this is an index of 3, so I'm going to circle groups of 3 for my numbers. Haven't even gotten into the variables yet. We do not want to forget about those, so we're going to extend this out. And I can write out 6 x's, 4 y's, and 5 z's, and do the same thing. That's going to be very tedious, but I'm going to do it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 2, 3, 4, 5. The reason I'm doing it with this first one is to show you that it is tedious and that there might be a better or another option. So I'm going to circle groups of 3 for this. Now, x times x times x really could be written as x cubed. So that is kind of be my other alternative method for this. We have 3 y's and then we have 3 z's. We have some leftovers. You might want to just highlight that or make sure, like I'm going to highlight what's left over in here. We have 2, we have a 3, we have a y, and a z. So make sure your circles don't hide those leftover pieces. And just like before, we're going to take out 1 from each group. We started out with negative 5 on the outside, so we want to keep that. Then we have 2 groups of 2's. 2 groups of x's, so I bring out 2 of those. We have a y and we have a z. And then we have our stuff that's left on the inside. Cube root 2 times 3 times y times z. And then just like before, we want to multiply everything back out, so we get negative 20. If we have 2 x's, we can write that as x squared, yz. Really make sure, especially so it doesn't look like an exponent, that you put that cube root nested inside the radical. So really make that check mark piece nice and big. And that's our final answer for that one. I'm just going to do one more of those and keep this video short, and then we're going to move on to multiplying, which has one extra step, but essentially is the same kind of deal. So we're going to be working with a fourth root now. And rather than writing out all of my variables, I'm going to still do my factor tree with my numbers. So 2 and 81, and then I know 81 is a perfect square. I can break that into 9 and 9, and then a bunch of 3s. Now you'll notice I stuck with the factor tree method. If you do not want to use that method and you want to go with something else, you can definitely do that. So I have one group of 4 3s. Now what I'm going to do instead with the variables is I'm going to kind of subtract. So if I do x to the 7th, I have x to the 4th. I have one of those, and if I subtract 4 from 7, I'm left over with x cubed. Do the same thing with y to the 10th. So I can do y to the 4th. If I subtract that, I'm left with 6. So I can do another y to the 4th. So I'm up to y to the 8th. And then I'm left over with y squared. Now I could write all of those variables out, but it's just going to take a lot of space. By doing this, I now can just say, okay, that's really technically 4 x's, 4 y's, and another 4 y's. So I can still put my circles in there so I know, okay, I have the -3 outside. I'm going to take out 1 from the first group of 3. I'm going to take out an x from that other circle. So for every circle, you're going to take out one of those things. I have a circle of y to the 4th, so I'm going to take out a y, and a second y to the 4th, so I'm going to take out the other y. Keep the fourth root, again, nested inside of that radical, 2x cubed y squared, and then you just want to remultiply everything, 9xy squared, and then fourth root of 2x cubed y squared. Final result. Alright, so I'm going to stop the video here, and then you have one more video to watch that involves multiplying.